Hi, welcome back to my Physical Science Online video supplement series. Today's short video, I wanted to work through a long-ish and somewhat complicated example for the physical science class. And this is an example in the thermodynamics and heat and ideal gas law part of the course, which corresponds to the 5th chapter of our textbook by Higgins, Wilson, Shipman, and Torres. In any case, this example is here to demonstrate the difference between taking the average of all the numbers and then squaring it, which would be this top thing, and on the other hand, taking the squares of all the numbers of some set and then averaging those. And the point of this example is that we have discussed that temperature is sort of a measurement of the average translational kinetic energy for a set of molecules within a gas, for example, or within a liquid or solid or whatever you're taking temperature of. And so the one question that immediately might follow from that is, well, if that's average kinetic energy, can we get the average speed? And so this is to show that there is something of a difference between getting the average energy, which would be basically taking the squares of all the speeds and then averaging them, and on the other hand, taking the average and then squaring it and using that to determine the energy. So for this example, I've chosen a basic set of data. We're going to basically pretend like we've got 5 cars that are basically identical, save that they're driving at different speeds. And what we want to find here is the average speed squared, and then also the average of their squared speeds, and then from that information find their average energy. So let's start out by just simply making ourselves this little table in which we're going to put the speeds of the cars. So we'll call that the speed in meters per second. And then the next column can be the speed squared, also in meters per second. So we had 5, 6, 7, 8, and 9. So if I was going to find the speed squared, this one would become 25, 36, 49, 64, and 81. Okay, so let's find down here the average for each column. So just so you can follow along, here's the calculator. So 5 plus 6 plus 7 plus 8 plus 9. And there are 5 of these, so we're going to get 7. So in this column, the average ends up being 7.00. And of course, if I wanted to find the average squared, that would be 49 meters squared per second squared. Okay, what about the other column? So in the other column, we've already squared everything, so we're going to go ahead and add each of these things together. So 25 plus 36 plus 49 plus 64 plus 81. And again, there's 5 of these things, so we divide by 5 and we get 51. So that means that we can put 51 as our average here. That's 51.0 meters per second squared. So you can see here that the order in which we do things matters. Now, what we want to know is what is the average energy of these 5 cars. And the basic way of doing that would be to figure out what the energy of each car was and then add them together and basically divide by 5. So recall that the energy for kinetic energy is 1/2 times the mass times the speed squared. And we were given that they're all identical cars that have a mass of 600 kilograms. So if we take 600 kilograms, that divided by 2, that's this 1/2 m part of it, we would end up getting 300 kilograms. So let's go ahead and write that over here for simplicity. 300 kilograms. Okay, so what I'm going to do here is I'm going to try to find the energy in joules of each of these cars. And let's go ahead and separate these guys out like this. So energy is 1/2 times mass times velocity squared. So that's going to be 300 kilograms times this speed squared term in each case. So let's pull up our calculator again. So 300 times 25 gives us 7,500. So we can write 7,500 right here. Then we do it again, and now we do 300 times 36. That's 10,800. So 10,800. Then we do 7 squared is 49 times 1/2 m. So 49 times 300. That's 14,700. So 14,700. Next one is 8. So 8 squared is 64 times 1/2 of m is 300 times 64. That's 19,200. And last but not least, 9 squared is 81 times 1/2 m. So we want to know what is 300 times 81. That's 24,300. Okay, if we're going to find the average kinetic energy, then we need to add these 5 numbers together and then divide by 5, and that's going to give us our average kinetic energy. So 24,300, I'm going to go in ascending order, so 19,200 plus 14,700 plus 10,800 plus 7,500. That's 76,500 joules, and that's distributed among 5 objects, so the average is 15,300 joules. So these cars have this average energy of 15,300 joules. Okay, so I suppose you could say that the follow-up question is, of these two numbers, which one is the one that actually is useful for figuring out the average kinetic energy? Because if it's this number we got by adding up all of the velocities, all the speeds, finding a simple average, which was 7, and then squaring it. So if this is the number that we use to get this, then by solving this thing for basically by solving this thing for the v squared term and taking a square root, you get the average speed. On the other hand, if this is the correct thing that you used, then by solving for a speed squared, you're solving for this term, and taking the square root is not going to get you the average speed. So how do we figure out which of these two it is that was used to find this number? Well, we can take this equation up here that we have for kinetic energy and basically solve it for the v squared term. So v squared is equal to 2 times the energy divided by the mass. So let's pull up the calculator again. This is the energy in question. We're going to multiply that by 2, and then we're going to divide that by the mass, which is again 600 kilograms. Remember, the mass is 600, half the mass is 300. Okay, and what we get is 51. So that means that we're actually using this method right here in order to get the average kinetic energy, which is another way of saying that if you're given the average kinetic energy and the mass, then the v squared term you find is actually this term right here, the square root of which is not going to give you the average speed. So if we take a square root, you get 7.14. If we wanted to try to get a simple estimate for what is the average speed, this method is probably going to work okay. Again, 7.14 is not that far off from 7.00, but be aware that there is some slight difference between the two. So that's what I'm trying to illustrate here with this example. And I think I'm up against the clock, so thanks for watching.